Okay, so hello everyone. My name is Christopher. A little about me. I'm currently a contractor doing some work at Home Depot with their mobile app. I recently just onboarded, so I'm kind of like junior-ish, somewhere in the middle. Um, so we're here today to learn about a little bit more about architecture components. Um, so has anyone here used architecture components before?
I have. Do you have any slides, Chris?
Um, Unfortunately, I do not.
Okay.
And yeah, it's been a long week.
You can
Um,
walk us through the codelab site, maybe.
okay.
So the architecture components is a package of APIs that is available on Android through the Android Play Store. So it's gotten interesting. The Google team found that if they wanted to iterate quickly and get APIs out to developers more easily, then the way that they should go is to um, use the Play Store to deploy the changes and the code that would run on the operating system. So it gets to be a little tricky if you want to distribute your apps in China or in other places that don't have the Google Play Store, parts of Africa, um, Korea. Places have different Play Stores, but of course, here in North America, you can pretty much count on the devices having the Play Store and being able to use the Jetpack APIs. That's what they call them, right, Chris?
Right. Okay. So let me share the screen.
I'm not seeing it yet. No
Okay.
rush. My mouse isn't working.
Okay. I just shared it. I might have to close and reopen because I'm on the Mac.
Oh, so you didn't the permissions, right?
Yeah.
All right. So yeah, go ahead. Let me see. Um, so how did the exercises go last week? Did folks get through the code labs that were part of the assignment? Okay. I am on the codelab site myself. And if I can get to the right place, I will bring it up. All right, so now I'm almost there. So, Paul, do you want to share some of what came up for you? I saw that you posted about the main activity and the detail activity. Usually there's a main, there's a template from Studio. It's not usually, but there's a template from Studio about the master detail view paradigm where, if you're on a phone, you see either the master or the detail, but if you're on a tablet, you can set it up so that both the master fragment and the detail fragment show on the larger screen.
And that seems to be what the issue was. I went ahead and put everything that the application, the instructions said to put in the detail. I went ahead and put it in the main, and I finally got it to work. But the instructions are not clear very much at all sometimes.
I hear you. So let's see. I am at the Android Developer Fundamentals class, and I want to go over to the code labs, right? So where were we? We were looking at I'm not sure this is the right place. Let's see. The recycler view? Was it the recycler view?
I believe so.
Okay. So I'm at the recycler view, and it's talking about some things that you might have gone over already, how to make the list interactive. Somehow I feel like I'm on an older version of the code lab, not the one that was created for the study jam. So if you bear with me for a second, or maybe you can give me a link, Paul, to where you got tripped up. I'm gonna come over here and see if I can find my right link. All right, here we go. Yeah, see, doesn't that look different? Okay, so then we went to start the course. Yeah, the code labs do get out of date, and I think it went to a new tab, and I got All right, now I'm in the right place. But we're through with, oh no, navigation. is this where we were? This is where I started. And then, is it the trivia app, Paul?
No, I don't think so. That one doesn't look familiar.
Let me go back one. That might be tonight's lab. So activity and fragment. No, we did the activity and fragment with Roman, right?
Right.
So maybe it's over here. Yeah, we're supposed to be looking at architecture components and the view models. So were you guys going ahead to what we're going to review on the schedule tonight, or?
Yeah, that's fine.
Okay. So the view model code lab is here. And when we talk about view model, what we're trying to do is we're trying to separate the business logic and the data that we're going to represent on the screen from the widgets and the views that are going to show on the screen. So when you're working on Android, what you can figure out pretty quick is about layout changes and configuration changes, so that if your phone switches from portrait to landscape, most UIs are going to have a wide version of the screen and a long version of the screen. And what happens when you make that configuration change to go from the wide version to the tall version, or the tall version to the wide version, what can happen is that the activity that's holding all of your data and views is going to get killed and restarted, right? So what you want to do is hold on to the data. Let's say your data is on the cloud somewhere, or it's in a SQLite database that's stored on the phone. What you want to be able to do is to hold on to that data and let the views that were tall go away and become wide views, but you don't have to go and fetch the data all over again, right? Because I/O is a bottleneck. Writing to the disk or reading from the network, that can get real slow. So the view model is a place where you're going to be able to track your data and keep it no matter what's going on the screen. Right? So here we are, and we're looking at the starter code, right? And we're talking about the navigation. Is this where the detail view came in, or?
It was a different code lab, but don't worry about that.
All right. So if we're looking at the view model, then we've got some starter code, the main activity with the main activity layout, and some new fragments, a title fragment, a game fragment, and a score fragment. Has anybody gotten started on this, or am I getting too far ahead? Not sure what happened to Christopher. Nab, do you see him on the call? Did he get reconnected?
Yeah, let me check.
let's see. There's that's a fair question. I'm trying to help Chris get reconnected. I am not seeing him in the list of attendees right now. Sorry for the mix up. Let's see if we can get Chris back or
Hey guys, how are you?
Chris is back.
Yeah.
Okay. So Chris and Nav, if you guys, I think I'm sharing my screen and I am looking at the Viewmodel codelab.
Yep. Can you full screen the codelab page?
Yeah, I was asking the same thing.
Okay.
Yeah, it makes more
And
sense.
zooming in.
Yeah. Yeah, it's a bit better now.
All right. So if I tap this link, we'll get over to GitHub, I think. And we can take a look at some of the notes on GitHub.
Can you zoom it in some more? It's you notice it's not taking up much of the screen. There we go.
Right. So this is the main activity, an app compat activity. But I think what we really want to look at in Guess the Word is the view model.
Yeah,
I'm afraid I'm at the stub. I don't have the completed codelab solution handy. But if Chris, if you have something ready, I can share the link. Now, if I stop sharing, you should be able to start sharing, Chris. Do you want to do that? Sorry about the mix up. We didn't really rehearse. Having trouble with my mouse. There it is. And I will stop sharing. See if you can get it. Aha. I'm seeing something.
Okay. Okay, are you all able to see the screen?
Yep.
Okay, great. So please let me know if it's too small. So here's the codelab. Now, Liz, you mentioned that there was about the codelab, like there was a part that was completed.
Well, let's just kind of walk through the steps of the lab, right? So let's go to tab 3 and explore the starter code.
Right.
So I think that's where we were, and we were talking about main activity and talking about how what our goal is to retain the data that we are displaying in the activity so that if it is killed to show the wide view instead of the tall view, that we would be able to
maintain that the state of the screen.
Yep.
Right. So
if you go back to the lab, I think we can look at the steps of the lab and get to the point where we're starting to create the view model. So
right.
if you go to task 5, where it says create the game view model, this might be a good place to talk about what's going on. So
okay, so here are recreating the view model. So since a view model is a life cycle component, an Android architecture component, well, now it's called Jetpack components. It's a library that needs to be implemented. So every time you're using a view model, you must use this library in your app build.gradle file. So it would go here. So I'm going to download this source and then go along.
That's the build.gradle that we talked about in our first sessions. And then if you go back to the code lab, we can look at the class, the view model class, right?
Right. Here the view model is being initialized. So here it's going through the steps on how to create the view model.
So when you're working with a view model, you might have a SQLite database, or you might have a network connection to a cloud database like Firebase or Couchbase. And so onCleared is going to tell you when that screen and that view model are going away so that you can clean up anything and close connections or unregister components like receivers.
Yeah, so if there are any resources your application is consuming, as Eliza said, like if you are connecting with databases or you are consuming highly resources like strings, or like if you're referencing to the context, which is like a like the major issue for a memory leaking sometimes. So on clear method is the method where you make sure that you clear up all the resources, so to make sure that you're not consuming resources afterwards. So for the view model, there is a two versions, like one is simple view model and the another one is Android view model. And if you want to interact with the components like Android framework related, let's say you want to work with room database, or you want to access some string resources from your view model, then you should you should consider using Android view model instead of a simple view model. So yeah, this is the main purpose of the view model. As it's, if you see the comment there, like game view model is destroyed. So here our main motive is to make sure that we don't we don't have still have references to any kind of resources that we don't want afterwards.
Right.
So we've got our game view model class, and we're showing how to end it, but we didn't really show how to start it or what we're going to put in it. So a view and a view model go hand in hand, and sometimes more than one fragment will share the view model. Do you want to talk about this game view model, Chris? Maybe show the diagram in step 4.
Here it is. So typically, using a view model, you can like instantiate it without using objects. But if you needed to use an object, then you would use a view model provider. So you can pass objects inside of your view model. So that's what this diagram is speaking about.
So yeah, so here if you see the diagram, it says like, as we already like earlier discussed, that a view model, it survives before, like after configuration changes. So let's say you are rotating your device. So if you are portrait and then you try to change it to the another orientation, your view model will still survive the changes, and everything that view model has, like if you have any kind of data state or any kind of states that your view model have, it will still survive even after that recreated fragment. So your fragment will still have access to that data, so it will not get lost at any point. So that's the main purpose of having view models. And if you see in the chats, I provided the, it's the KTX library for creating view models in like just in one word. You just simply say by view model, it's a delegate provided by that library. So you can just use that. If you want to, like as Eliza said, like if you want to share data between multiple fragments, you can use the activity based view model, so that the two fragments, let's say A, B, they have common like the base, like the activity which holds those two fragments. So you can use the activity based view model to share data between those two fragments. Or if you want to have the like a fragment specific or fragment tied view models, you can simply say like by view models. So yeah, these are the two main categories that how you can use view model in your fragments.
Right. So if you scroll down a little bit more, Christopher will look at code. So the style shown here is a little bit of an older style that might be a little bit easier to understand than the library that Nav is talking about. Maybe it's not easier, but this is the way that the codelab is explaining it.
Yeah.
I
So
would
I think
definitely encourage you
to
to
yeah,
look at the Kotlin extensions.
yeah, to
This,
understand the concepts, I think this is good way actually how those
yeah,
delegates working for you guys. Like it's just a wrapper over these kind of things, so just to provide a more concise way. So if you see the code after number point number 2, like how you initialize the view model. So if you see, it says view model provider, and in the brackets it says this. So this means like this view model will be only attached to your current fragment. So if you want to get an instance for your activity-based view model, instead of passing this, you can provide like get activity or require activity, which is the host of your fragment. So in that case, your view model will be activity-based, and that you can use in your multiple fragments.
If you want to share it, you're going to use an activity, and all of the fragments associated with that activity can share it. Alternatively, each fragment can have its own view model, and that's pretty common because usually the screens are really different. But if you have different states with the same data, it's both of those patterns, both of those styles are in use. And the extension library that Nav is pointing to is the way that a lot of folks are doing it in Kotlin, but the older style that we're showing you here is helpful to learn it so that you can use those extensions and adapt to Kotlin a little bit more. So like he said, the Viewmodel Provider parameter, that's going to be an Android context, a fragment or an activity, an Android view, set of views that's an Android screen. And you won't have a view model without some views. And when the activity goes away, so does the view model. But as long as that activity is around, you can get the existing view model from that provider. Have you noticed that even when an activity is not on the screen, it's still alive? I mean, when I first started with Android, that always surprised me. I expected that when the activity went off the screen, that it would be dead and gone. But fragments and activities have a way of staying in the cache, hanging around, and Android does that in order to be able to return to a screen that was already rendered very quickly and to have good throughput and good responses for end users in a resource constrained environment like a mobile device. Is this making sense, friends? I think we can scroll down a little bit more, Chris. Keep going through it.
Here it's just logging the Viewmodel Provider. It's like every time you rotate it, this would show. And here it's showing that it was also destroyed. So I'm going to move on to the next page. So here we're populating the game view model.
I have the codelab open in my browser as well to follow along. I would encourage you to speak up, share where you've been working. So now that we know how the view model is getting created and managed inside of an activity or a fragment, we can talk about some of the objects that we use in a view model, right? Are you working with live data at Home Depot, Chris?
Yes, we use that pretty often.
How do you use it?
I mean, me personally, I'm not exactly touching it, but it's there. A lot of the code is kind of already set up, so just go on and add new features or fix bugs.
Right. So we've looked at how a view model gets created, and we look at what happens when we're done with the view model and we're leaving the app or going to another screen. Task 6 here to populate the game view model is about um, what goes inside of the view model and is persisting the data in case of a screen rotation, or in case we go from master detail. We're in the master view, we see all of the list. Then we go into a detail view, we look at the details of one item in the list. Then we go back to the master view. So the data for the master view, when we go into the detail view, can be retained in the view model.
So yeah, so here if you see in the diagrams, if you see there is a live data, it's basically a observer pattern. If you heard about the design patterns, so whenever you want to push your update any UI, or let's say you want to show some new data in this codelab, it's a game fragment. So every time you want to show a new score, you just post your change onto the live data, and then you are observing. If you just scroll down your screen a little bit, Chris. Yeah, yeah. So if you see here, so the view model will be hosting your all the data related functionality. Like it holds the live data where you publish your changes, and in the UI side, like in your fragment, you're just observing that data, and based on that data state, you just update your UI. So you don't need to manually perform any checks in your view model, like what's the state of your current state of your data, or current state of your whatever you want to say, like objects or anything like that. So here it's basically this step, which is like populate the game view model, is basically how you're gonna tie up your data and view model combined together to use it from your fragments. So I will post the link for live data where you can just go through over like the overall definition and how it works in Android in the chat. So you can take a look there.
In the chat. Great.
Yeah.
Cool. So live data right here is just kind of mentioned. The next lab is more detailed about the observer pattern and live data. But the idea is that we have some data in the UI. We have the contents of the list. And let's say the list in this master detail view has the title showing in the list summary, and then you navigate into the detail view and you change the title. Now you want to have that data be alive and valid when you return to the list. You want to see the change that you just made to that title. So it's more than just configuration changes. It's also how the data might be updated when you go to another screen, and when does that update occur? Let's say the data is updated in the cloud. by another person looking at the same data that you're looking at. How is the Android app going to manage that? And live data is a way to alert the views that are on the screen about a change without necessarily interrupting the user and what they might be doing on another screen. So let's see. If we look at the data fields and data processing to the view model, now all along we've been kind of getting a string and putting it into a text view. And we've been doing that all in one place. Now what we're talking about doing is keeping that string separated from the text view and tracking it inside of the view model. Does that make sense? So Chris, what kind of things have you seen in the view models that are on your day-to-day app work? There's usually some good data structures. There might be strings pulled in from backend. I mean, at my work, we have a backend team, and we are constantly exchanging data that's represented during an activity, during a workout activity.
Right. So with my work, I work with view models, and of course there's repositories, and it's like the pattern it's typically followed. And yeah, like it's like the view model is like typically there to hold like data that's being changed often, as you mentioned before, live data. And yeah.
Cool. Well, maybe we can follow that link that Nav shared. How does that sound? Should we take a look at the
Okay.
So I hear you guys saying that the codelabs are a little out of date, and I myself got lost in an older version of the codelab just trying to catch up with you guys tonight. But one place you can count on is d.android.com. So there's a lot of reading materials, guides, and articles about practically using Android APIs. So if you're looking at the, I got a different link looking at the live data one that he just put up last.
Whoops.
Yeah. Well, the first one was good too.
Yeah.
So here what we're looking at are some kind of high level discussions about why you want to use live data. But you guys are convinced already, right? You guys are on board to use live data here. So if we scroll down, you can see a longer list of advantages. So what you used to see before a lot of these components, these architecture components were ready, was that you would get a change in the data and you would try to update a widget, but it was not on screen anymore, and crash, boom, there goes the app. It's an illegal state. So let's take a look at the part where we're actually working with live data. So has anybody looked at the kind of reactive observer patterns in your recent history? Well, it's common practice to kind of keep the keep the live data connected to the activity and observing when there's a change. If the activity goes away, then nothing happens. If the view isn't on screen, then nothing happens. The live data has the most up-to-date information when that view comes back. And there's kind of a more subtle piece that I wanted to share with you, which is that a lot of the time what you have is a public live data that is shared with the activity, and it's assigned to a private live data that's mutable and changeable. So the private data is the one that gets updated inside the view model, and it's assigned to be the value of the immutable live data in the activity. Because if you change the live data from the logic inside your activity, you kind of defeat the purpose of putting it into the live data to begin with. There's like a separation of concerns that's discussed in a lot of these observer pattern and reactive conversations. How about you, Nev? How do you work with live data?
Yeah, so I think I'm using most of the time. It's now like for observing, like loading data from network. So managing the different states of the app. Let's say when we are like loading data, we show some kind of progress bar on our app at that point. And when data is like loaded from the network layer, we just hide that state, like hiding the loading state and then showing the valid data state. And if the network's response is like not good that we are expecting, so then based on that we show some kind of error state. So it's really helpful for like just observing the state of the data, like whatever is currently active, we just use based on that we just update a UI by using like
That's
observing.
that's an excellent point. That's something that I've worked with too. So Nav is talking about a view state. And the view states that I've worked with are what he said: loading, error, and then just data, like the real state when everything is on the smooth and golden path and all the data comes through as you expect it. That's kind of the content state. So there's three states, view states, and they're transmitted to the activity via live data. So the live data might have a loading state and show a progress bar spinner. If the loading doesn't work out, it might go to an error state, and that'll trigger activity on the views that'll show an error about what went wrong, so that if the user is disconnected from the network, for example, they know what to do. They can get connected. They can be informed that the reason the loading didn't work is because there was no network to get the data from the cloud, or something went wrong reading from the disk. That happens too. And then, of course, the content state. So view states are another big pattern that goes along with live data. It's not specific on the Android developer site. They're talking about the observer pattern more generally. But these view models and view states are very, very commonly used in app development, Kotlin development. Chris, do you use view states?
Not that I know of, no.
Right. Mark Murphy, somebody that I'm working with, is a big proponent of those 3 view states for every screen and every fragment. It's a nice paradigm that you can implement, and it makes it easy to navigate the source because you know what to expect. If every screen has a loading state, an error state, and a content state, then you know what to expect when you are working on the different screens in an established and built out app. So working with live data objects is one thing. Let's scroll down a little bit more and look at creating them. So here you can see we're inside of a view model, right? That's where the live data is going. So the view model code lab is leading you into the live data code lab. And if you haven't noticed already, there's a Kotlin tab and a Java tab when you're on the site. And that can be helpful if you're still just learning Kotlin. You can go back to Java, your old standby that you know and love, and you can look how it would be in Java. You can see the Java equivalent of the more concise Kotlin code. So now what we've gone and done is we've added a mutable live data object, and it's going to hold a string. And lazy just means that we're not going to instantiate it until it's needed, until it's called. I'm not calling you lazy. The code is not calling me lazy. It's just a nice keyword from Kotlin that we can use. So this is what I was talking about, where current name is mutable. And instead of having that be a val that's open and public and can be read inside of the activity and changed by the activity, what we might have is current name and current name value. We might have 2 live data objects, and the current name value would be mutable, and the current name would be immutable, but assigned to be the current name value, to observe the current name value. And then the current name would be shared, but the outside classes couldn't change it. Only the view model could change it. So then if we scroll down a little bit more, we get one of those blue stars. The developer site has some patterns in the way that they present information. And so here you've got some tips about how to use live data in the view model. And they're telling you that you want the view model to update the live data, not the activity or the fragment. So you can do that by being disciplined in your coding, or you can do that by setting up 2 live data, one immutable and one mutable, if that makes sense. Are there any questions? Are we doing all right here? This is some of the more important logic for really creating Android apps. So let's scroll down a little bit more and take a look at the last piece. And this is where you're actually going to put your view model into your activity. So you got your view model, you put your live data in it, and now you're going to observe the live data and you're going to see how it shows up inside of the app compat activity, right? So here on the developer site, it's a little bit different from the codelab. You see that by view models? That's what Nav was talking about with Kotlin extensions. It's a little bit more concise than going and finding the Viewmodel Provider. And now if we go a little bit further into the onCreate, we're inside of an activity. We're going to create the activity and inflate the layout XML. We've looked at all of those things before. It's not new. But now what we've gone and done is we've taken that string that we're going to apply to our text view and we've put it outside of the activity into a view model. And inside of the view model, it's in a live data. Anytime that string changes, it's going to be observed by this activity. And so what you've got there is a new object, the observer, and the generic parameter that you see there, string, that's what you're expecting to get back from the live data. So you've defined the live data to hold a string, and here you've defined the observer to read a string. So the view model is persisting and saving the string, and the observer is going to be how it gets from the view model into the views that are on screen from the activity. And you've seen the dot text equals before. So in this val name observer, what you've gone and done is define a lambda. And you can give a name to the string that's coming in from the live data in the view model. That's called new name. And now you take the name text view that you got in the XML and you assign the text. Name text view dot text equal new name, right? And then after you've defined the observer, you need the observer to call observe. And sometimes you might combine these calls because you can chain calls in Kotlin, same as you can chain them in Java. And that's pretty essential Android programming stuff. That's where we are. It wasn't always like this on the Android platform, but that's kind of where we are now. And where we started today, we were talking about using Kotlin multi-platform, using Flutter. Those cross-platform mobile technologies are using this same reactive live data and observer pattern. So I hope that makes sense and will help you get through the code labs that are part of this session. Nav, did you want to talk about the observer and how
I think pretty much you covered, but still I think, yeah, as Lisa said, like we are observing in the activities, if you see here, and then our responsibility is just to observe data here, and then view model will be responsible for updating any changes to that. If you want to, like if you want to update the name text, so let's say from new name is going to update at some point, so you just, all that logic should be in view model, and then you just holding this, like just observing that state in your activity. Yep. So I think pretty much like that.
And the way to change that data, you can scroll down a little bit more, Chris.
Yeah.
Is to set the value. So
there is a version like so the live data is like just a readable version where you can't change the values, so you just observe that. So that's the main purpose of the live data. So what we are basically doing, the best practice is like we create the mutable live data properties in our view model, and we push the changes to that. If you see in the example, like whenever user clicks the button, we call the model dot current name dot set value, which is like a current name is a, I think it's in a view model, and it's a type of mutable live data of type string, and we were passing the name here. So it has two variants, as you see on the in the docs, set value and post value. So there's a like there's a major difference between those two. So set value is whenever you try to change the value from your UI or from the main thread. So by main thread I mean when you are interacting with your active, like the Android has a main thread, like all the UI logic or all the UI processing is done on the main thread. So in this case, like if you want, like let's say you have a field where user can type their name and you want to update that value based on that input. So in that case, we can use the set value. And the post value is when we want to update the value from some another thread. Let's say we want to fetch data from network, and when we get that data in our repository layer, at that point we are not on the main thread, right? So from that point of view, if you try to call the set value, you will get exception, because that's not gonna work. And in those scenarios, like if you are not on main thread, you should use a post value, and that is how it works. So next time whenever your main thread is in active state or your application is in resumed state, it will observe the state of your live data and update accordingly. So there's basically two things. So first is like you create a mutable live data in your view model. So that is the property where you can push your changes, like in this case name. So you call set name into that mutable live data, and then using the live data, you will observing the changes to that mutable live data. So whenever there is any change, your live data will be automatically observed, and you can update your UI from there.
right, and if you want to be strict about it, and there is a strict mode that you're probably going to trip over sooner or later, but it's a good idea to have all of your I/O, network I/O, disk I/O, any
Yeah.
I/O off of the main thread. There's a certain number of frames per second that the main thread should be having to render the screen. And if you're doing I/O on that thread, it's going to drop frames and look bad for the person who's looking at those views on screen. So we're getting toward the end of our time for session 3, and we do have another door prize tonight. So tonight's door prize is going to be a smart light starter kit for a smart home. If you had any interest in programming actions with Android and with Google Assistant, You'll get a couple of GE smart LEDs that can change colors and turn on and off according to an API. Just fill out the form. I just posted the link to the form, and we'll do that wheel of names to share our door prize tonight. Last week I got into a little trouble trying to send to Canada from the Google Play Store, but I did get a mini out, and Jake was our first winner, and he got the Chromecast. And don't forget, next week, that's going to be our last session. Jin Kim, the other organizer of the GDG Boston Android, is going to be presenting our last session, and you all are invited to step up to the mic and show us what you've done in your codelab and in your time on the study jam to win a pair of Pixel Buds. You get some nice new earbuds to go along with your Android programming skills. Roman, are you here? Are you going to help us with the Wheel of Names?
Yes, I will. I just dropped the link in the chat for people to put their names in. I see a couple of responses already. So thank you everyone for participating, and good luck to everyone. I just wanted to say again, thank you organizing team, Liz, Nav, Christopher. You guys have provided great, amazing input. So let's please give a +1 to everyone. For their efforts and so much expertise being provided. So thank you guys for that amazing session.
Oh, you're welcome. We're proud to share what we have learned with you all. I want to thank everyone for coming. I'm going to stop the recording. We don't need to track everybody's names on the wheel. Awesome. And